This is your Unit 4 quiz review video. So we are going to do 4 equal subintervals for this. So I'm going to go ahead and circle them. 1, 2, 3, 4. And please do not simplify any of these down. All right. If you do that, I'm going to have to do that, and that's going to be frustrating. All right. So the length of each subinterval is 2 units. And so for my left sum, I'm going to use all the values on the left of the interval. So this is my first interval. On the left, I have 2. Second interval on the left, I have 4. And then 10, and then 20. Right sum, same thing, but I'm going to use the right side of the interval. So it's going to be 4, 10, 20, and 34. Midpoint is going to be the values in the middle. So those are the ones that we didn't use yet. And trapezoidal. So a trapezoid formula has a 1/2 in it, just that's part of the formula. And then it's the height, which is the length of the subinterval. That's this same 2 that we've used in all of them. And you're going to use the end points just once, and then everything in the middle twice. So the 4 gets used twice, 10 gets used twice, 20 gets used twice, and then the end points just once. The ones in the middle get used twice because they're shared between the subintervals. If you write it out the long way, you'll get to see that they are in the summation twice. But this is the more abbreviated way to do it. You can only get away with this if your subintervals are all uniform. So if they're all equal length. All right, for this one, we're going to use our properties. We're going from 2 to 12, but we have a break at 7. So if you want to write it out, if you go from 2 to 7 plus from 7 to 12, that's going to give you the length from 2 to 12. So think like a road trip where you have a break at 7. This is poor notation. Technically, each one of these should say f of x dx in it. But I'm doing this sort of as a margin problem, like a note to self, so it doesn't need to be absolutely perfect. All right, so from 2 to 7, they tell us is -5, plus from 7 to 12 is the thing that we're looking for. So I'm actually just going to go ahead and call that x, equals from 2 to 12 is 9. And then if I add the 5 over, I'm going to get 14. All right, here we're just going to write one or more integrals. All I'm having you do is practice setting up an integral. Literally, that's it. All right, so this one is going to be from -π/4 to π/2. The function is 2 cosine x, and you have to put a dx at the end. That is all I'm looking for. I'm just having you practice writing an integral. Now this one's going to break at 2, so our first integral is 0 to 2, and that's the x squared dx. And then we're going to go from 2 to 6, and that's the -x plus 6, the linear one, dx. So the first one would give us this area, second one would give us this area, and we're just adding them up. All right, indefinite integrals means you do not have boundaries. This one I'm going to rewrite first. So notice I'm keeping the integral symbol and I'm keeping the dx. I'm not actually doing the antiderivative yet. I'm simply rewriting it so that there is a negative exponent. You're going to add 1 to the power, so it's going to become less negative, and then you divide by that number. So 4 divided by -2 would be -2, and you must put plus c at the end, or I will have to take off for that, and I don't want to have to do it. The derivative of e to the x is e to the x. So the antiderivative of e to the x is e to the x. And then for 7, you get 7x. And again, please put plus c. These ones are not going to get plus c because they are definite integrals. You actually have boundaries. You're going to get a numeric answer. You are finding the actual area under the function from here to here. So you will get a numeric answer for this. So antiderivative of sine is negative cosine, and we want to go from -π/2 to pi. I like setting it up blank, put something minus something. On your unit circle, pi, I will draw you a picture, is on the left. It is this coordinate point. Cosine is the x part of the point, that's -1, but we're going to negative the -1, so just 1. -π/2, that means you rotated backwards, so it's going to be down here, 0, -1, Again, cosine is the x part, which is 0. You can't negative a 0, so just 0, and so your answer is 1. All right, antiderivative for 1 over x is ln x. We want to go from 1 to e to the 7th. Again, put your parentheses in, upper boundary minus lower boundary. So if you plug in e to the 7th, ln and e cancel out. You will just get 7. They're inverse functions, so they undo each other. And then ln of 1 is 0, and you do need to just know that. If you want a visual, your ln function has a vertical asymptote at 0, looks like this, and you have that 0.10 on the graph. So ln of 1 equals 0. I like a graph. I'm a very visual learner, so I like having pictures. All right, average. If I gave you a list of numbers and asked you to average them, you would add them all up. That's what an integral is. You're adding up all your rectangles. You're adding up all of your area. And then you would divide by however much you've got. So in front, you're going to divide by 4 minus 1. So 1 over b minus a basically is what you're doing there. Inside of the integral, we're going to just put our function, and then basically you just work that out. So in front, we've got a 1/3. I'm going to do an antiderivative. So 3/2 x squared plus 1/3 x cubed, such that I'm going to go from 1 to 4. I'm going to come over here, and you don't have to evaluate this. I'm going to keep my 1/3 out front, and I'm going to do upper minus lower. So just be careful with your brackets and parentheses. A bracket is just like a big brother to a parenthesis. You can just put another parenthesis if you want. I just do a bracket to make them look different. So we're going to plug in 4. 4 squared is 16. Divided by 2 is 8. Times 3 is 24. And then 4 cubed is 64, which does not divide nicely by 3. So I'm just going to leave it 64 over 3. That 3 is really ugly. Let me fix that. Ugh. I can't write on whiteout. There we go. Now it's pretty. All right, if we plug in 1, that's going to just give us 3/2, and then plus 1/3. I do not want to figure out what that simplifies down to. You would have to get a common denominator with all that stuff, and I'm not doing that. All right, for this one, we're going to use our picture over here. We have a triangle, which is 1/2 base times height. The base is 6, and the height is 2, so that's actually just 6. Semicircle is 1/2 pi r squared. Radius is 3. So that is 9/2 pi, but it is negative because it is below the x-axis. And we're just going to use that to answer the question. So from -4 to 8 is the whole thing. So 6 minus 9/2 pi. This is the whole thing, but we're going to treat it all like it's positive. So just put a plus instead. From 2 to -4, you're going backwards from here to here. So that will be -6. And then an average value. So you want 1 over 8 minus -4. And then integral -4 to 8, f of x dx. We already did this part right here. It is the 6 minus 9/2 pi. This integral from -4 to 8 is the 6 minus 9/2 pi. We just need that fraction out front, which is going to end up being 1/12. So this is our answer.